Rectangle ABCD is comprised of 4 right angle triangles. So here we see that these are 4 right angle triangles and the triangle ADI and CBG are identical. So ADI and CBG, these two are identical triangles and the other two also are identical triangle. These two blue triangles have area 96 while the other red triangles have areas 150. If the side of each triangle have integer lengths. So this is really an important information here, because with integer length, if we have to find the area of a triangle as 96, so half of a multiplied by b is 96 and 96 is 12 into 8, so a into b becomes in a way 12 multiplied by 16. Now the question is, why exactly am I writing it in the form of 12 multiplied by 16? Then the reason of writing it in this way is that 12 and 16 are forming a particular kind of Pythagorean triplet. There are very specific right angle triangles that GMAT is interested in, and one of them is the triangle 3, 4, 5, and if you multiply all of them with 4, the triplet becomes 12, 16, 20. So let's assume that these are the sides, which means that the smaller side is 12, the GC is 16, and with these two sides, the third side BC will be equal to 20. So that's what is the understanding that we can start with. We are not saying that these are for sure the sides. Similarly, when we look at the other triangle, which has the sides 100 and area 150, so half of C multiplied by D is equal to 150. 150 can be written as 15 multiplied by 10, which means C into D can be written as 15 multiplied by 20, which means if we say that this side CH is 15 and DH is 20, then the area of this triangle can be 150, and in that case the third side, according to the same Pythagorean triplet which says 15, 20, 25 also could be the side of a right triangle, this side becomes 25. Now with these assumptions, we have to start thinking that is there any relationship between these two triangles? Then a very important fact is that these two triangles actually are similar triangles. Let's prove it. If this angle is equal to x, then we know that this entire angle is 90, so this angle remains to be 90 minus x. And if this is 90, so the third angle at point D will be 90 minus x, and the third point angle, that means at point B, the angle will be 90 minus x, so that is x. So now these two triangles are similar because their angles are same, and the ratio of their areas we know is 96 over 150. Both are divisible by 6, so it gives us 16 over 25, which means the ratio of the sides of these similar triangles should be equal to. Now let me just quickly remind you about one thing, that the property of similar triangles is that the ratio of areas is always equal to the square of ratio of their corresponding sides. So S1 over S2 square should be equal to 16 over 25, which eventually gives us that S1 over S2 should be equal to 4 over 5. Now if our assumptions are correct, then this condition should be met, because this is the fact as per the given inputs. Now since we have taken this side as 20 and this side as 25, let us see what is the ratio that we get. And 20 over 25 also is a ratio 4 by 5. That means here it's confirmed that our assumption is exactly right on track. Now to find out the area of the rectangle FGHI, that means this is a small rectangle, we have to just subtract the area of these 4 triangles from the area of this rectangle. That means area of the rectangle, which is 25 multiplied by 20, we will subtract 2 times 150 and 2 times 96. And if we do that, we have 500 here, we have 300 here, and we have 96 multiplied by 2, so 192. And if we subtract the two things, the resultant is 8, which should be the area of the rectangle FGHI. So the answer should be option A. That's what our answer is. Thank you so much for watching this video, and please remember the Pythagorean triplet and the similar figures property is really an important thing to remember, because it has a great usage in different difficult questions. Thank you so much for watching this video.